Hi, it's Mr. Wassman, and once again, we are looking at our study guide for the end of the year assessment for everyday math in fourth grade. This page has problems 8, 9, and 10, and each problem has a couple of parts, so let's look at these one at a time. So 8a is asking you to compare these two fractions. Are they greater than, less than, or equal to each other? You're going to notice that both of these fractions have a different denominator. So one of the things you would have to do is you would have to convert one fraction to have a like denominator to the other one. So as you can see, 5 and 10 are related to each other because 10 is a multiple of 5. So the way you would go about figuring out what is the equivalent fraction in tenths is that you would have to figure out what would you multiply times 5 to get you 10, and you would multiply the same amount to 3, and that would give you your answer at the top. And then that will help you solve whether or not 6/10 is greater than, less than, or equal to 3/5. And then you would just basically describe how you would know. Now the next step, or problem 8c, has two other fractions with unlike denominators, and again you would have to figure out what is the equivalent of tenths that is the same as 1/2. So you'd first have to convert 1/2 into tenths. So what times 2 gives you 10? You'd multiply that same number to the top number, the numerator, to get your new numerator. And then what you would have to do is you would have to create a fraction that is bigger than 1/2. So how many tenths is equivalent to 1/2, and then what would be a fraction that would be bigger than that? And then you would explain how you came up with that answer too. Number 9a says Joseph adds 3 fractions to get an answer of 3/4. What might his equation be? So I need to add 3 fractions together that would equal 3/4. So I might look at that this way. 3/4 equals some fraction with the denominator and numerator plus a second fraction plus a third fraction. And what might those fractions be? Now remember, when we add fractions, we are only adding the numerator. We have to keep the same denominator. Natalia subtracts 2 fractions to get an answer of 1/2. What might her equation be? Okay, so again, a subtraction problem is going to give us an answer of 1/2. So we would need to figure out a fraction that would be bigger than 1/2, and then subtract something from it that would leave us a difference of 1/2. And then finally we have number 10. Decompose or break down 7/10 into 2 different sums of fractions with the same denominator. Record each decomposition with an equation. Then justify each decomposition by coloring the parts of the circle. So, let's say right here, I shaded in one of those tenths blue. And then I shaded in some more tenths so that I had a total of 10 tenths on my circle. 7 of them are shaded in. Now, one of those fractions is 1 blue tenth. Oops. Let's use the right color here. 1/10 plus another group of tenths, and that gives us 7/10. So your job is to figure out how many other tenths do I have to add to 1/10, which was in blue, to give us a total of 7/10. And then I would go about creating a different equation. Oops. So let's say this time I used red and yellow. What would be my equation here? Noticing that I have a different number of tenths that are shaded in one color and a different number of tenths shaded in a second color. So how many tenths are red? How many tenths are yellow? And what would that need to give us a total of 7/10? Okay? The problems are set up for you. All you have to do is do the legwork and do the calculations. We'll talk again soon. Thanks.